Kyneton the Genius, and today I'm going to be explaining to you some of the questions and answers in statistics that you might encounter at some point. I'll try to explain this concept in a very simple and clear terms, and I also have, you can see the screen open there. I use it to actually illustrate by actually drawing or deriving some equations for some of these concepts. So the first one, and also remember to subscribe to my channel if you've not subscribed, so that you kind of motivate me to keep making these lessons for you. And if you have any questions, feel free to ask me in the comment box below this video. So the first question we are going to be looking at is what is biased and unbiased statistics? Clear explanation is given in my website, kynetonthegenius.com. That is what my website is. So let's look at biased and unbiased statistics. Now, in the definition I have, it says we talk about unbiased estimate, statistic, estimator. These three are the same. So make no mistake about it, because sometimes it can be confusing in textbooks. So you can have statistic, and you can have it called estimates, and you can also have it called estimator. So all of them are the same. So unbiased statistics means that the calculation or the estimate you made is equal to the value of the parameter you are estimating. So let me illustrate it so that it becomes clear. Let's say we have a population. I will have to actually use real numbers so that we calculate it and see how it works. So at this point, let's say this is a population. We don't know how many, but I have decided to choose some random numbers to put in there. So we have 4, 3, 2, 4, 1, 4, 5, 0, 4, 3. Okay, let's say this is our population. We want to take samples from this population and calculate the mean. So, and if our estimate of the mean of this population is unbiased, then it means that the mean of the sampling distribution of that statistics will be equal to the parameter being estimated. Let me clarify. Now, if you take a sample, let's say from this data I have here, the population has how many items? Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maybe 12. So we take 3 items at a time, and that is called a sample. For us to have a sampling distribution, we need to take several samples. And based on these several samples, we are saying that the mean of this sampling distribution is equal to the mean of the population. So first, let's calculate the mean of this population. The mean of this population is 3 plus 3 plus 4 plus 2 plus 4 plus 1 plus 4 plus 4. So we have, let me take another color so that it becomes clearer. So we have 3 plus 3 plus 4 plus 2 plus 4 plus 1 plus 4 plus 4. So I have 3, 3, 5, 0 remaining. Okay. So plus 3 plus 3 plus 5 plus 0. If you total everything and divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it will give us 3. Okay. So now in this population, we've not taken any sample, at all. So in this population, we have the population mean to be 3, okay? Now, this population mean is not known. We are trying to estimate it. So let's assume that it is not there. Let's just close our eyes and assume that this population mean actually is not there, okay? So now we want to start taking samples and try to estimate the mean of this population. So we take the first sample to be 4, 4, 3. So we take 3 items, 4, 4, 3. So this is our first sample. Okay. Is it 4, 4, 3? 4, 4, 4. Let's take 4, 4, 4. This is the first sample, and we calculate the mean. to be equal to 4 plus 4 plus 4 is 12 divided by 3 is going to give us 4. Okay, so this is our x1, the mean of the first sample we're taking. Let's take another sample. This time we are taking 4, 3, 2. Take note that this is the mean we have. Now we are not saying that we know the population mean. We are just calculating the mean of our samples, and we are trying to make an estimate. 4, 3, 2 is going to give us x2. This one, the mean of this data will be 4 plus 3 plus 2 is going to be 9 over 3, which will give us 9 over 3 equal to 3. In this case, we have 12 over 3 equal to 4. So this is the second mean that we have. Let's take another sample. This time we are taking 3. We take 3, we take 2, we take 1. 2, 1. And that will give us a mean of 3. Let's call it x3 is equal to 3 plus 2 plus 1 over 3, and that will give us 2. So now we've gotten a number of samples, and now we are sure that we have a sampling distribution. Theoretically, we have a sampling distribution because we're taking a number of samples. Now, if this estimate we are doing is unbiased, then the mean of these samples, the mean of this distribution, that is the mean of this means, will be equal to the mean of the population. So now we have how many items? 3, 4 plus 3 plus 2. So we want to find the mean of these 3 items. And that will give us, let's say, mean of sampling distribution will give us equal to 4 plus 3 plus 2 all over 3. And that will give us what? This is 4 plus 3 plus 2. That will give us 9 over 3. And that will give us 3. So let's compare it to the mean of the population and see if it's equal to the mean of the population. So if you look at, we got 3, and we have the population mean to be 3. It means that our sampling, or our samples, they can be said we are taking unbiased statistics. So I hope this is clear, and I'd like to remind you to subscribe and also read the explanation, because you should be able to know how to describe or explain what we are talking about here. I'd like to thank you for viewing again. Remember to subscribe. Leave me a comment if you have anything that you feel I need to know.